Let's start my session. So at, at first, today's presenter is two persons. First presenter is me, Naoto Yamaguchi from Aisin Corporation. Second presenter is Harunobu Kurokawa from Renesas Electronics Corporations. We are a member of Instrument Cluster Expert Group. First slide shows the motivation for Instrument Cluster Expert Group. We aim to create a base platform for instrument cluster, not a platform based on conventional IVI. There are different system requirements between IVI and cluster. For example, instrument cluster requires functional safety adaptation and more severe boot timing and etc. So this platform is built from open source technology. It's a good, most important point for AGL project. In this case, so need to independent from existing proprietary software component, and need to be able to choose open source software component or proprietary software component. So Instrument Cluster EG mainly focused to how to build open source Instrument Cluster Linux platform. This point is most important point for us. Paths in open source Instrument Cluster Linux platform. So there are many paths in the open source Instrument Cluster Linux platform. So for example, IVI requirement is a rapid innovation. That means new features are added, short-time development, and rapid bug fixes. It's a IVI side requirement. On the other hand, instrument cluster side requires the advanced quality management. This means, so for example, the full patch coverage testing, formal verification, and carefully bug fixes. It's a big puzzle. Another point is IVI requires various functions. Many pre-installed applications is including, and application installed from software. That's IVI requirement. On the other hand, instrument cluster side requires the selected functions. These functions require to the combination verification and fast boot up time. This is a big puzzle for one these function integrated into one Linux platform. Our approach is as shown. Our answer to the puzzle issue is open source one more isolation method, which take one more layer to isolate the functions by using Linux container technology. This figure shows abstracted architecture. So instrument cluster and the IVI and the other function isolated using the Linux container technology. It's our concept. So main function are isolated according to the QM level by the Linux containers. The verification side isolated the other functions using container technologies. And the other bug fix issues for IVI, it realized by the Linux container technology. It's our concept. We call to this concept QM isolations. What is a Linux container? Linux container is an operating system level virtualization method. So Sorry. It's running multiple isolation Linux systems. It's a container on a host using a single Linux kernel. Key feature is isolated root file system on Linux kernel by using change root. Control resource such as the CPU isolating, CPU resource isolating, and memory limitation and isolating, and another solution is by using the C groups. Hide resource from other container by using the namespace functions. And more good point for the Linux container, it's easy to use in embedded environment. Because Linux container require to use only Linux BSP. No need to additional virtualization driver development, and can integrate the container based system over hypervisor. This slide shows the AGL Instrument Cluster status update. Around 1 year, we are released LL and MM releases. AGL ramp released in July. ICZ upstreaming start in this releases. LL release includes the most basic integration feature. It was merged. And this release supports container integration using the Yokt multi-config technology. Marine released in March in this year. In this release, some core software was merged. Some development issue is fixed, and some demo software merged to evaluate an AGL Instrument Cluster architecture. It's an overview of our activity. Status for ramp release. Limited container hosts and cluster container is available. Display isolation feature is integrated, but it supports single display only, not supported multi-display. Demo GUI is available, but it supports a standard demo only. Support container image building using Yokt, and Arca H3 and M3 starter kit without Kingfisher board support only. Status for the Marine release. In this release, some common software was merged. First is the IC service framework is upstreamed. Multi-display support is upstreamed. Guest network support upstreamed. And the firmware downloading and the input device support for IVR container is upstreamed. And some demo software was merged. This means in LL release only to support the cluster container. Marine release upstreamed demo IVR container. It's based on our SS demos. And extended board support. In LL release only to support Arca H3 and M3 starter kit without Kingfisher only. In this release, Arca H3 and M3 starter kit with Kingfisher configuration and AGL reference hardware support. So what is most interesting feature? This answer is DLM sharing. So DLM sharing talked by the Kurokawa-san. Kurokawa-san, please talk this information.
Can you hear me?
Yes.
Yes. Thank you, Yamaguchi-san. I will explain the DLM sharing part. So DLM sharing is needed for multiple container support. So basic design. This system has two containers, IVI and cluster. These containers have display connection for each. And these connectors have compositor inside a connector. However, there is issues. So the DLM device is controlled by only one process. It's called the DLM master. The DLM master is usually assumed by compositor. It means that the only one compositor can manage the DLM device. So that in this case, the secondary compositor cannot access the DLM device. Then, so in ICEG, we create a DLM release manager to realize multiple containers using the DLM release kernel features. Now, this kernel feature is inside after the kernel version 4.15. I will explain the DLM release manager. So basic design. The traditional DLM master, the file descriptor is created by opening the device file. And it creates and resets manager tasks that takes on this role. As a result, each compositor that using the DLM controls resources. The control flow A, the DLM release manager open DLM device and create a RESI DLM master for each client. B, this release manager sends this file descriptor to both clients when it was required. And C, these clients render directly to their own DLM device using the releases. Let's see. Finally, D, DLM release manager revokes releases when the client is finished with it. It's a basic design and flows. So I will explain the current status. This DLM release manager is already available in AGL Lamprey and Marine. The future is 2 or more DLM clients can launch it at the same time. For example, in this case, Wayland compositor. And the dynamic transition feature is also available. The ownership of the resources can be transferred from one client to another client. So you can use it adding to AGL DLM release features when you using the AGL setup script and see also the documents. And I'll explain the ongoing development. We need to support 2 or more DLM resources to one client because current existing DLM manager only release one DLM resource to one client, so that the Wayland compositor does not display 2 monitors. So that we are now going to development. And so the configuration files allow the user to specify the mapping of DLM connectors to DLM release. it becomes easy to set the customized list name instead of default DLM name. For example, so current DLM name is card 0 HDMI A1, so that it was easy to use IVI list. This feature will be available in next release, Needlefish. And also, we are discussing the product use cases. For example, the cluster screen shows a part of the IVR information, so such as a map, a music track, and ACs. So our proposed design, for example, so IVR container has and render two display images. One is a center display images. And second is another one is a sharing image for cluster displays. And it shall be rendered onto the virtual display. And also cluster side, cluster image also render another channel of the virtual display. And so both images shall be composite, hardware composite. Then final image shall be displayed onto the cluster displays. In this case, it was required virtual display and composition inside the hardware compositor. This implementation is highly dependent on the SoC or BSP specific drivers on, so that we, the Renesas or SoC vendor, need to discuss inside a cluster EG. That's also my part. So I'll back to the Yamaguchi-san.
Thank you, Kurokawa-san. So, and last talk is some demo software merged, some software information. So, IC service framework and other feature was merged, and IVR container is now developing, and some feature was merged. This image shows the current status for our demo integrations. Available for the instrument cluster on cluster display, and available for demo navigation software in the IVR display. And one more application is a media player. So these are board support status. So our starter kit only case only to support the single display and the cluster only integrations. So Kingfisher and the reference hardware case supported the cluster and infotainment integration. It can use current MM release. It's available. So finally, task for this year. So we are planning to this year, so good practice sharing and continue to develop some tasks. So handle the input devices and the dynamic devices. This means such as a network interface, Wi-Fi, Ethernet, and another interface, and USB device and other dynamic devices. And continue to work the OSS assessment. It's our quality management work. Finally, it's a conclusion. So please check this slide, and if you think to interesting our activity, please join to our Instrument Cluster EG weekly call. Thank you.